Hi everyone, John here. Welcome to Menthor YouTube channel. In this short tutorial I'm going to present how to implement your model into the OWL language. OWL is used in the Semantic web, in the context for instance in the linked open data to publish the content of your model in the web. Also as a knowledge representation language to discover knowledge by running inferences and so on. So we have here a model represented in OntoML showing that people can be enrolled in schools, that schools function in a set of properties. The model represents a very specific type of property, which are homes that people can live in. We have that properties are located in a city. We have also families here, which are a set of composed by a set of people, a set of members, and so on. So this is our model. And then if you want to transform your model into OWL, just go to the top of the tool and click and transform, and then an item is going to appear called Semantic Web OWL RDF, and then a dialog of configuration is displayed, where you can choose whether do you want to see the content of the transformation into a tab. Mentor editor will open the content into a tab, or you can choose to transform your model into a file, an OWL file. So there are 7 approaches of the transformation. 4 of them try to deal with the temporal notions embedded in OntoML, like rigidity, anti-rigidity, and other things like that. Reification, warm view 0, warm view 1, and warm view 2. These 4 tries to deal with that information, because OWL is a very limited language. If you consider a conceptual model, which is a very complex model with a lot of axioms and so on, we have a simple transformation, a very straightforward transformation, but which is not very rich. We have also the last one, which is currently being developed. So we are going to choose the first one. It does not consider a lot of temporal notions like rigidity and anti-rigidity, but it also considers structured data types, cardinalities, transitivity of material and parthood relations, the disjointness between substance sorters, and so on. It also considers OCL constraints, which is very important. So the transformation generates swirl rules to represent the constraints. So we see that in other tabs you can choose which elements do you want to transform, if you want to just bring a diagram instead of a package, and so on. We see that you can choose which axioms do you want to enforce in the transformation. This is very important, because according to your purpose, according to your technology, you may want a very specific type of resulting specification that can have high performance and so on. So you can enforce some axioms here, the binary properties of relationships like reflexivity, symmetry, and so on. You can choose the reasoning here. You can choose to transform the rules or not. We also have here the ontology IRI, so you can choose the address here. You also can choose specific mappings that the transformation is going to consider. Which primitive type do you want to transform, and which primitive type in OWL is going to be mapped. So you can also choose, for instance, we have strings are transformed into this very specific data type in OWL. and so on. You can also try to map attributes, in particular primitive types. You can, choose other types of mappings like qualities and generalization sets. We have a lot of options here, so maybe you can check them out later. I'm not going to talk about them here. So if you want to transform your model according to your configuration here, just press start, and then the file is going to be generated, and then I'm going to open this file with Protege just to show you the content of the transformation. That here we see that that model, our conceptual model, represented in all. So you see that there is a structure about UFO here, like we have object, collection, functional complex, and then the domain entities come right beneath this structure. Like family is a type of collection, so we have that house, home and apartment are functional complex. So we have here below the properties, the mapping of the relationships of the model. We have here domain, range, the inverse of the property, and so on. So as you can see, this is the result of the transformation. So the next video I'm going to show you other types of implementation that Menthor has. And thanks for watching. Make sure you can download the tool at menthor.net, and see you guys.